Hello, my name is Rob O'Connor. I am the head coach here at Nazareth School. We are team 16617, and I've been doing this for maybe the past 5 or 6 years. Wanted to take a minute with some of the newer teams and explain, maybe show exactly what it takes to get your robot programming and running. And it doesn't take too much time if you know what you're doing. So let me help walk through some of those things. We're going to go through the basic setup for the new control hub. It removes the cell phone on the robot, and we'll go over the basic wiring, configuring the robot. We'll get all through these things as nice and smooth. Hopefully you can ask questions when we get to the end, so jot questions down as you go, and I'll do my best to answer whatever questions that you've got when we get through to the end. If you think of something later, I've got my email address on the screen for you, robert.o'connor@nazarethisd.net. So here we have a basic push bot. It's not the exact push bot design that First puts out, but it's pretty close. It's got just a 2-wheel drive down here on the bottom. I've got 2 Tetrix motors, standard gearboxes. You'll notice that there's 2 types of wires that come out of here. You've got your red and black, which is your power, and then you've got this other wire that you can plug in, and that's your encoder cable. Your encoder cables and your power cables. They come out of your motors, and you'll feed them into those control hubs or the expansion hub. Now, you may ask yourself, what is an encoder? Encoder is a counter, and it's inside of here. What it basically does is it tells you how far around your wheel has come. And it's got a lot of measurements. To make one full rotation, it counts 1,440 times. And so you can tell it to drive forward 1/10 of an inch, 1/4 of an inch, 10 inches, 50 feet. And it'll get very close to the same thing each time. And we definitely want to make sure that we get precision out of our robots. That's where you stand to get the most points, if your robot can do the same thing over and over again. So the start of that is making sure that your encoders are being used. So just to guide you through the wiring process, I've got this motor here plugged into my control hub, and I've got my rear right motor plugged into my expansion hub. So I'm going to show that everything is working in the end. Now, to pick this up a little bit here, you're going to see that your power is square, and you've got the rectangular 4-prong for your encoder just below. And the same thing you'll see down here on the expansion hub. We've got our power and we've got our encoder cable. The rev hubs are powered by a 12-volt battery pack. The battery packs, I want to say there's 2 or 3 of them on the market that we're allowed to use. They all have the same amp ratings, so I don't think that any one of them is any stronger. It's not going to give you any sort of competitive advantage. The different shapes of the packs might make it easier to build a robot design that you're interested in. Next, here on the back, we've got a servo, and these are used to make small parts on your robot move. You can put a gear on them. They make continuous rotation servos that just spin and spin. This is just a standard servo. It's got 1 degree, and it'll go over to the other extreme, or anywhere in between. Servo is not meant to, typical servos are not meant to continually rotate. They're meant to hold a position and turn to another position. That's about all they're good for. So they're good at pushing buttons. They're good at moving and manipulating things. They're good at hands, grabbing, all of that. That's where your servos come in handy. Now your servo is going to plug in to this bottom rail on your control hub, or you'll find another control rail on the bottom of your expansion hub. And you're allowed to have a lot of servos on there, 10, 12 servos or something like that. The next thing I'll show you here is this is a connector cable between the control hub and the expansion hub. They don't connect wirelessly. This is how they communicate. It's not USB. You plug this tiny little 4-pin wire that goes in the same port on each one. Now, down here on the expansion hub, I have used one of the I2C ports. I2C is just a type of connector. It's a communication language that the computers understand. I've put on a color distance sensor version 3. This has a built-in LED light. You can kind of see that yellow there. So it'll shine a white light out as it's trying to do its color and its distance measurements. And it's all built into one little device. We're just going to go over the color part of it today. And I have plugged that into I2C port 1. Now, there are other ports and other plugs on here. I'll just try to keep it simple today. I'm going to go ahead and flip on the robot. Now that the robot's on, you're going to see some green and blue flashing lights that show up on your control hub and on your expansion hub. If you've got anything plugged in, some of its lights might start showing up. That's all normal. The first step in setting everything up, and you can find this on Rev's website too. Let me just take a quick second. All I do is I Googled Rev Control Hub setup, and I'm following this through on the guidelines that they had. I just went here and followed their startup guide. I've also watched this setup video for this fella here. They'll walk you through it too. I'll just give you whatever thoughts I had as I went through my journey in setting this one up. First thing you'll do is head down to your network access. If you're in Windows, you come down here or go up to the top bar on a Mac. You're going to look for a network ID that says FTC and a number, or it might say first and a number. And you'll click on it. I've already changed the name of our unit here. If you're not using the same computer with the robot all the time, then I would tell it not to connect automatically. But if you are, you can click that button. And your passphrase for when you're getting started is password. And one of the very first things we'll want to do is change that password once we get things started inside the control hub. So you'll bring up any old internet browser. I'm using Chrome. I've had pretty good luck with that. And you'll need to type this in, 192.168.43.1:8080. That's an IP address, and that'll get you right into your cell phone. Once your cell phone's all loaded up, you're going to go, you can notice here too, it's going to tell you what the name of your phone is and what the password of the phone is. Under your Manage tab, this is where you're going to change to the regulation name. This is going to change the broadcast ID for your Wi-Fi. So this is changing the name of the phone in the old terminology if you are still used to doing that. So I changed it to our team number, and I put a dash for robot controller. There's RC, and then I believe you're allowed to use a single letter initial after that. I put control hub there just to try to keep things easy for me to understand, but I'll change that later when it comes competition time. When I hit change name, I had to do a restart on the robot. I had to shut down the power in order to get that to come back up and reconnect to my computer. So you may have to do a robot restart in order to get connected back up again. So when you hit change name, expect to have to reconnect to the network ID, because it will drop it and you'll have to find it again. Next, you'll update your password, so something other than password. You might do something about your team. Make sure you make it complicated. Later on in the competition, you just don't want anybody to get access to this. If anybody can get into this system, they can access your program. They can change your program. They can edit things while you're on the field, and you don't want that to be able to happen. So make sure that you update your password. Once your password's changed, again, you'll have to come back down here and reconnect. It'll ask you to enter the password again, and you can save the password again. So if you've got some of the newer phones that have 5 gigahertz channels, they are recommending that we use those 5 gigahertz channels when we go to competition. Most everything else has been running on 2.4 gigahertz, and some of those channels get really clogged up, and the competitions are just becoming overwhelmed. So if you've got new phones and you can run these 5 gigahertz channels, you want to do that. It'll make some of the connection issues that we've been having in the past hopefully go away for you. Next, I want to go over how to update all of the firmware and all the pieces for this. So the first thing that I did was I updated the control hub operating system. That's this part down here. So to get to the control hub operating system, I just Googled it. And you can download the latest version of the Control Hub operating system. Once you've downloaded the file, you can also download, I think down here is the expansion Hub Firmware. All your software has to be up to date right before every competition. And some of the later competitions may require you to have a certain version of the software. So you're going to want to make sure that you've got all of these up to date. So once you've downloaded those pieces, those files, you will find them in your downloads folder. So if you wanted to update, you'll open this up, and I did notice that I did an extraction on the control hub. You just use the zip file. You don't have to extract it or anything like that. So once you've downloaded the control hub operating system 1.1.1, you're going to hit open. and then down here it's going to ask you if you want to update and reboot. Hit update and reboot, and it'll verify everything's good. You're going to do the expansion hub firmware the same way, except with the expansion hub firmware, it's going to install the software onto the control hub, and then from the cell phone, you're going to be able to update the expansion hub's firmware. And again, you want to make sure that everything's got the most up-to-date software. Sometimes there's bugs, sometimes there's security patches that they put out there, and they make things run a lot better. Now, when you're updating the robot controller app, that is released, I don't know, 3 or 4 times a season. They tend to release updates for the apps. You typically just download them out of the Google Play Store, but now you're going to have to go into the FTC Github. So I'll show you how to do that real quick. So I don't know what next year's game is going to be called, but so I'm going to type in Skystone, you can APK, GitHub, and that'll take you there. Once you get in, all right, so once you're at the, it'll say First Tech Challenge and whatever next year's game is, you'll navigate down to Dock, and then you'll go to APK, and then you'll pick the robot controller. The driver station, you won't need to update that from here. But you'll get this and you click on it one more time, and then your download button is down here. You download this little guy the same way that we did before. Come over here and update the robot controller app. Select the app, and it'll find in your downloads. There it is. Click it, hit open it, and then again you have to hit the update button, and it'll update. So there's a quick little crash course on how to update your control hub and get all that set. All right, so now we've got the control hub set up. We've got the control hub updated, we've got the network name updated, and we've got the password updated. Next, we're going to want to connect our driver station. So you'll go into the Play Store, and you'll look for the FTC driver station app. All you can do is a quick search for it. First Tech Challenge, and it's a driver station. And once you pull up your FTC driver station app, you'll download it and install it. I've already got that done here. So once you've got the app downloaded, you open your FTC driver station app. Click on your jelly beans here and go to Settings. From Settings, Wi-Fi Direct is the old way where we would connect 2 phones together. From here, you're going to tell it you're going to connect through a control hub. Now, once you've got that control hub set, you're going to need to go into your Wi-Fi settings and tell it that you want to connect to the phone. So you find the phone, and whatever your password was, you're going to type it in again. And make sure it's not password. Once this has connected, it's not going to have any internet, but that's just fine. You're good to go. Now we hit pair with robot controller, and there we go. We are connected. Robot controller, we're set. Now I wanted to make a quick note. In the past, we had to change the address or the port for the expansion hub over to number 2. The control hubs are on number 2. So if you have an expansion hub that you're using from last year and it's still set to number 2, they will conflict. But by default, the control hubs are set to 2 and the expansion hubs are set to 1. And so they shouldn't, if you have all new equipment, conflict with each other, and you won't have to change or worry about any of that. But if you're an old team kind of looking back on me here, there's just something that might help you out. So now that the control hub or the robot controller is connected to the driver station, we can configure the robot. And by that I mean we make a little file that's going to put a name to every motor and to every sensor, to every servo, and those names are going to match letter for letter inside the program that we're going to create. To do that, you click your jelly beans and press Configure Robot. I've already created one that I'll walk through in just a minute, but to start one from scratch, this won't be here. You're going to click the new button up top, and it should do an automatic scan for you and pull up. So the Expansion Hub portal, it's just kind of the first little window. Under here, you're going to have Expansion Hub 1 and Expansion Hub 2. I would change the name of Expansion Hub 1 to Control Hub, because it's actually the Control Hub. Once you've got that done, I think things are going to just make a little bit more sense. You see, you've got motors And so you've got the 4 motor ports starting with port 0, and all of those numbers match when you start looking. If you can see my fingers over there, there's a 0, 1, 2, 3, 4, and a 0, 1, 2, 3, 4 on each of the hubs. So here, I'll just hit cancel and go over to the one that I've already set up. All right, so let me edit this one. This was my test, and so I changed the name of that portal to just portal 1. And here I've got my control hub 1 and my expansion hub. If I scoot this over here, I think you'll be able to see the robot. So when I'm talking about control hub 1, I'm talking about this unit. And when I'm talking about the expansion hub, I'm talking about the gray unit. And so when I click on the control hub, these motor ports are going to talk about these 4 plugs over here. The servo ports are going to talk about these along the bottom. Your digital devices over here, and analog input devices down here at the bottom, and then your I2C each have their own. So to go through and show you what I've done here, you get port 0 to match up with this one, which is in port 0. And I told it that it was a Tetrix motor. There are several choices, so you can buy motors from whomever vendor you like the best, or even just an unspecified motor if you don't want to tell it that. And then I come up with a nomenclature that I always use. I call it a motor, or I call it a servo, or I call it a sensor, and then I put underscore and then where it is on the robot. And so I did that here. Next, I'll show you where I did in the servo. I've got the servo in port 0 over here, and I just called it servo. I might typically identify what the servo is by putting, claw or something along those lines, if that's what it was a part of, just to help have some sort of designation there. On this unit, I don't have anything else to kind of show you. However, I will point out that I2C bus 0, like I said before, is by default set as the expansion hub's IMU. That stands for Inertial Measurement Unit. It's going to work like a gyroscope to help your robot drive on a continuous heading. Again, I won't get into the details of using that function in this because it just gets too complicated and probably too long for our meeting today. Now, I'll hit cancel again, and I'm going to go into the expansion hub. And so now I'm talking about this unit. Now, if you notice here, we've got another set of motors, and I'm not in the top motor port. So this motor is in port number 1. It's the same type of motor. And then I use the same nomenclature with the motor rear right. And last on this unit, we're going to have I2C bus 1. I chose Rev Color Sensor 3. There are modern robotics, gyroscopes, infrared seekers, range sensors. Rev made a 2-meter distance sensor at one point in time. So you just come down here and pick up whichever of these devices that you've purchased. Plug it in, give it a name. All right, so once you get your configuration profile all done, you save everything. I'm working my way backwards all the way to the end because I don't want to change it, and then you activate it. Once it's activated, you're going to see it pop up on the front page here. So right now, that's the one that I made. It's called Test. All right, I have configured my robot. Okay, so we have built the robot. We've wired it up. We've gotten connected to our control hub. Everything is established inside. Everything is updated. Everything's connected. The phones. Now we've got our configuration profile. All right, what do we do now? There are 2 languages that you can program in. I am not going to do blocks. I'm going to do on-bot Java, which is Java. So you click here, and this is where it all happens. Java is a pretty simple and fundamental computer language. I'll say that I started out in college as a computer science major, but then I thought to myself, this is not for me because I don't like Java. And so here I was several years later as an FTC coach getting stuck, trying to figure it out again, even though I totally got a D in computer science in college. But it's not beyond you. You can do this. So the first thing that you'll do is you'll create a new file. And you don't have to start from scratch. There's already examples in here. So you can go to these samples and they're going to give you examples of how to do almost everything. So when I need to figure out how to use a new sensor to do something, I come through here and I use it to kind of understand what happened, because you can play these programs and they'll help you. You just plug it in, and as long as you're configuration of the robot that you just created matches all the nomenclature for the hardware, it works. All you have to do is change your profile or your configuration profile on your phone to match whatever it says inside of here. I'm not going to get into that because I want to try to keep it simple today, even simpler than that. So I'm just going to focus on pushbot is typically where everything works from. So this hardware pushbot file, it's not an op mode. That means it doesn't run directly. And so if I were starting off, I would just go here and type in the same exact name that they have down here at the bottom. And do that. You should follow the same nomenclature here. I had some issues when I tried to rename this file, so just go with it. Call it hardware pushbot, and I'm going to put a little 1 after it, just that way I don't get it confused with the one that I've already created. And it'll pop up for you. It'll automatically bring in the information. Now, everything that's in green in Java is just words. It's there to kind of explain some things. This part up here at the top, it's all fluff. It's copyright stuff. So I can delete that. And then it's going to have a lot of other information for you here to look through. So this is the basic one that you'd start with if you were creating your own. So I've already updated it and edited one of these. So I'm just going to remove this one and walk directly through the one that I made, so that way there's not any confusion. I can also copy and paste this out or put it in an email or something along those lines. So let me hit delete here and remove pushbot Java 1. And be double careful when you're deleting stuff off of here, because once it's gone from here, it's gone. There are no backups unless you copy them out and save them to your computer, okay? So your hardware file. It starts by importing information from other parts of the program. What you see here is just the surface level that we program at. There are layers deeper, multiple layers of information that I don't ever mess with. I haven't had to mess with it. So when you get here, you're going to see that at the very top of this, it's going to start importing a package. It's going to start calling up all this stuff. And right here at the end is where it matters. That's for DC motors. This tells it how to use a color sensor. This tells it what this hardware map thing means. Servo. And then a utility for counting time. So all of those things, they usually get put in there on their own. And it's rare that you would have to type one in on your own. A lot of times if you just type public DC motor down here, it's automatically going to pull this thing in because it knows it needs it. Now, there's a lot of little basics about Java, and it's very linear. It's very logical. And the whole program, it just reads it line by line and goes all the way down. Now you can put loops and tell it to go backwards, but everything is always going to follow this general logic. It's going to go from the top to the bottom unless you told it to come back and go and do something else. So the very first curly that opens up here, so you're going to say it's opening something that's public. So this means other files can access it. And it's creating a class called hardware pushbot. And this curly cues can be the end of things in Java. It's going to go all the way and match the other one that's down here at the bottom. These two are partners. They pair off with each other. And everything has to fall within those curlies. Next, you start calling in motors, servos, color sensors. So I'm going to say here, I'm going to call a DC motor, and I'm going to give it the name left rear drive. Going to give another one the name right rear drive. I've got two motors, so I need to have two different names to identify them in the program. And I'm talking about the motors in the back of the robot, so you can kind of see what I'm talking about here. Again, we're naming those two motors. The next thing that we're going to set up here is the spike servo, and then the little color sensor that I've got kind of dangling around the robot. All right. So after you've named all of your motors, your servos, and your sensors in this part, it moves down into creating a hardware map that you can access from other places. So here it is, public hardware pushbot. This is what we'll call on from other places. And then it will use this initialize function here on the hardware map that it's creating. So it's doing some things. It's storing these concepts, hardware maps, as variables, so that can be manipulated and edited by the software. So it's going to take your color sensor, and so this is what we called it up here, as you can see. and then you're going to set it equal to hardware map. Now this is where it gets particular, color sensor.class. This, let me bring it up over there, has to match the configuration that you set in your phone. So this right here, this color sensor, these have to be identical. Case, all of it has to match to the letter. So you put that inside those colons, and you end every line in Java with a semicolon. So I hope that will help kind of clarify where these two different things patch together from. So after that, we're going to identify the motors. We've got left rear drive. Again, we called it up here left rear drive. We said it was a DC motor. And down here we're saying that the hardware, that DC motor, it's mapped to this inside the phone. And that the right one is mapped to that one inside the phone. Then we got to do a couple of other things. Right now the motors are facing opposite directions on the robot, so if they're both going to go forward is forward, they're both going to all go in opposite directions, and your robot's just going to spin around in circles. So with that in mind, we can do a set direction. So following this logic here, you type the name of the motor, dot set direction, and then you just type all this stuff in here and either tell it reverse or forward. And it sets it to work and spin that way. So that way positive values mean forward and negative value mean backward, and you don't have to try to do anything funny in the program, and it all makes sense to whomever is programming. Next, I want to give, this is more of a tip. This isn't required. This is zero power behavior for the motors. I set my drive motors to brake so that way my robot doesn't roll past a certain point, and it's much more consistently programmed. So it's safe to set brake mode to your drive motors. It might burn out a lift motor if you have one. Just keep that in mind. And then we're going to tell this that we don't want these motors on. We want their power to be 0. So we've called up the motors. We said that this thing that we identified up above, it's mapped to this hardware. We've set our directions, 0 power behavior, and we don't want it to be on. We want it to be off. And we're setting its mode to run without encoders. It can also run with encoders. We'll get into that in a little bit. And then the last thing that we did was we set up the hardware map for the servo, and we tell it to set its position to 0.2. And that's a hardware map. Now we're going to get into the program. The one that I've written here, I pirated this off of some code that my kids have written. I'm just going to make this go away so we can see a little bit more. There, that's better. That's a lot better. So you'll see that we have the same process as the other file did. And you can copy this and use this to help you get started, okay? It's going to import all of the stuff that it needs to run this. It's going to look for op modes named autonomous. It's going to look for range utilities, hardware utility, and so whatever. It just pulls in all the information from the other parts of the program that we don't need to know about. That's what this top part is. All right. Next, this part here, this is important. Bring this other little guy back up to our attention here. So if we are here, this little part that says @autonomous is going to make the program show up here under autonomous. If this says teleop instead of autonomous, it's going to put the program over in this list on this side. All right. So, and it's also important that this be a unique name. The group can be the same group, but the name needs to be unique or the phone will throw an error when you put it in it. The software here won't when you try to build it, but you want to make sure that in the phone you've got everything set right. So you'll see over here, this one is called test encoder. That's where that goes and how that links to what you would see as a student user. All right, next we're going to go ahead and say public class test. This is the name of the file. First thing it's going to do is it's going to go after that hardware pushbot file. It's going to give it a variable off of that file. It's called robot. and then it's going to take all the configuration from it. So anytime we want to call up something from that file, we say robot dot whatever we were looking for and use it. Next, we set up some variables for this software. So again, we've got this section here. It's kind of its own little chunk. This is the start of the program with what you're going to see on the phone, and this is what starts the program. So you're going to see there's some pretty clean breaks in the programming language here where different trends and patterns start. So then we called in the hardware from the hardware configuration that we made just a moment ago. And then after that, this starts setting up some variables. It wanted something to count time, so here we have that. And then we set up a bunch of, this all came from the pushbot configuration file, guys, so this is, I'm just using what they gave me to use. It set up some variables. This is how many counts per rotation on each of the motors. If you wanted to set up a drive gear reduction or drive gears on your robot, calculate. Right now this thing is set up for a direct drive. No gears, just goes straight on the motor. If I were to add gears, and I were to gear this up or gear it down, I were to increase torque or decrease torque, I could use this number and count the number of teeth and come up with the ratio, whether it's 0.5 or whether it's 2 or whatever. And in the end, in theory, the same program that I wrote today, which moves the robot 2 inches, would still move the robot 2 inches even if I added gears to it. Likewise here, it's using a formula later on that uses the wheel diameter. So if you were to change from like 4-inch wheels to 2-inch wheels or to 6-inch wheels, in theory, the software would then be able to update for you and make some of those changes to your software for you. So it would be just a matter of swapping the wheel off of your robot and then changing the diameter size here. And then we set variables for drive speed and turn speed. If that doesn't make too much sense to you, don't worry about it for now, because we can, again, we're storing numbers as words, so we can easily call back on those same numbers. We're going to want to use them over and over again. All right, so now when you come over here on your phone and you select the program that you want to run and you hit initialize, if you click this button, this is what starts happening. Okay, so it goes robot.initialize and it pulls in the hardware. It's going to check it and make sure that everything matches up. And if you have mistyped anything in your configuration file, you might get an error on the phone at this point. The first part that I did here is I stole this from some color sensor stuff. Let's just say it's color sensor stuff. Just trust me, it works. Come down here. This is a little telemetry update. So this is telemetry. That's all that means. Right now it says robot status is stopped. And anytime you hit this command here, telemetry update, it's going to update what you see down here on the bottom of the screen. So what we did here, next we reset the encoders, and we set the mode to the motors. Remember, robot dot, and left rear drive, right rear drive, and we set them to run using encoders. It's part of what we're wanting to do. And then this is an interesting telemetry path here. It's going to tell you add telemetry, and it's going to give you start at. This is what you're actually going to see on the screen. Start at. There's going to be a few other things that you're going to see. See path 0, start at 0, 0. So this number comes from this and this. So that first %7D is this first 0, and the second %7D is the second 0. And the number of commas that come after this string here, if you put another one in there, maybe you had a third motor that you were wanting to record values on, you put that in and then you duplicate this thing kind of the same way and just follow it by another comma and a space, and you would tell it just change its name to whatever the motor was, and you can get its position as well and just update that and would add a third number there. Next, I pulled color data off of the color sensor. So I told it here to start storing some information into hue. So it started pulling that information here, and that's all this is. It's saying that the color function for red, green, and blue to whatever hue separated value or something like that, and it's scaling everything so that hue isn't some tiny number. It's multiplying it by 226. And then the last little part down here says to add data from alpha, red, green, blue, and hue. And hue is all that other stuff. Sometimes you would want to use alpha. That's what we used last year. Quite a bit of alpha for light and dark. In years past, we use a comparative for red and blue, which one's greater, and that helps you figure some things out, being red team or blue team. And this, I like doing this because all I got to do is hit stop and initialize, and I can use that color sensor that's on the robot and just point it at stuff and find out what its values is just by hitting stop and initialize. And it's just at the start of every one of the programs that we've got, and it allows us to do a quick check when we're on the field and make sure that we don't need to adjust any of the alpha value, the red value, or anything along those lines, because sometimes those change depending on the light of the environment that you're in. Okay. Again, if you've got questions as we're going through this, I totally understand. That does the update, and this part right here is the next main break. So initialize is this. The next part, it says wait for start. It means it's waiting for you to press play, the play button. So the kids are going to press play, and then it's going to do whatever it's programmed to do. So we're going to go over some very basic programming sets. The easiest way to program something is by time. There are some serious downsides to using this function. But it is also very easy. So if you're just in a quick pinch and you need your robot to do something in autonomous mode, just drive forward and get under that sky bridge, this is the trick for it. You tell it, robot, left rear drive, set your power to 1/2. Now in Java, you can go between 0 and 1. If you give it a value over 1, it's going to kind of freak out. Or negative values, it can use those and invert the power. But if you tell it here, set your power to 0.5, okay, that motor is going to turn on at half power. If you told it negative 0.5, it's going to turn on backwards at negative 0.5 power. And so I wanted to turn them both on so that the robot would go forward. And then I got to tell the program line, like the program goes fast, like as fast as the computer will go. I don't want it to keep going. I want it to wait. So I tell it to go to sleep for 5,000 like microseconds or milliseconds or whatever this is. So that means 5 seconds. If I wanted it to be 1 second, it's 1,000. If I want it to be half a second, it's 500. And yes, we do use half seconds or even in 0.25 seconds. It just depends. Because when we've only got 30 seconds for an autonomous mode, you need every moment in order to get your robot through everything. And then once it's done, you need to tell the robot's motors to turn off. That's it. So if you wanted it to go forward, that's how you'd make it go forward. If you wanted it to go backwards, you just add negative signs in front of the power levels. Or if you wanted it to turn, I think this would make it turn right. Did it the other way, it would turn left. And that will follow through for you. So you can program this way. And so all of this together tells it to drive straight for 5 seconds. Downside. If your battery level is high or low, it's going to drive a different distance because the power level that it has at its disposal is different. So now let's start talking about the encoders. It's going to count the number of rotations that the wheel undergoes, and it doesn't matter how much power there is. As long as it has power to move the motor, it's only going to stop after it's met that condition. So you see how all of these lines up here made it drive forward for 5 seconds? Well, this one line here makes it drive forward 2 inches. That's because it's activating a method. Methods are a way of compacting all of this. So all of this information here, I could write it into a method and compact it. The method goes down at the bottom of the program. So in essence, this is saying here, find the method Encoder Drive and plug in these values. Plug in this drive speed. Plug in this distance for the left wheel, for the right wheel, and this is a timeout. So again, the encoder drive that they gave you, it's in the program, and I just copied it, has 4 values: the speed, the distance, and a timeout. Distance for each of the 2 wheels. And a 5-second timeout. If 5 seconds passes and it doesn't get to the 2 inches that it's supposed to achieve, then it will go on to the next line, which is supposed to make it turn. Now, let me go over methods. Methods can be a little confusing, so let's go over this. The encoder drive method, you're going to find it down here. So in order to write a method, it follows, it's after, like this right here would be the end of what we were asking the robot to do. So to make the robot do stuff easily up here, you can take multiple lines of code and throw them into a method. Sorry, I went a little too far. So all of this little bit here is ridiculously complicated compared to all of what this is happening, even though it looks simple. So we're taking the numbers from up there and putting them down here. So if you notice here, public void encoder drive, it's got speed, and remember a double lets you store information as decimals. And then it's got left inches, right inches, and a timeout. It's set up a couple of integers. Again, these are whole numbers instead of the doubles, which are decimals. We've got a new left target and a new right target. These are used below to figure out how many ticks it needs to rotate the wheel. So to come up with the target, it's going to use this integer, and it's going to say that this number, it's equal to, okay, we're going to take a look. All right, where's that robot? Okay, that left rear wheel, what's its current position? All right, so if its current position is 10, it's going to add however many inches you wanted and multiply it by counts per inch. Now, remember all those values that we put up at the top of the program? I'm going to kind of highlight this so I can find it back. All the way up at the top of the program, we set up all these variables, and I told you we would come back to them. So up here, you see that the rev motor has 1,440 counts per rotation. We've got drive gear reduction, we've got the diameter, and now counts per inch. Counts per inch is equal to the counts per the rev motor, 1,440, gets multiplied by the drive gear reduction, and then all of that gets divided by the wheel diameter times pi. Okay, so yay, that's a lot of fun math there for folks that don't like math. But it's super duper helpful, and you don't really have to do much other than plug these numbers in the right way, and then the computer does all the work for us afterwards. Now you come in down here, and it's going to just convert. You told it 2 inches, and it's going to make sure that it converts it to the right number of counts for the motor. You're talking thousands of counts for 12 inches. Now, and then it's going to set the target position to whatever the new left target is. So up here we said new left target, it's an integer, and then we assign the value to it, and now we're going to tell, okay, left rear drive, your target number is, and we do the same thing for the other wheel. You're going to change its run mode to run to position. Once it's on, run to position, you got to feed it power. Now, what this is doing, it's taking the absolute value of speed because it's using the position number that you gave it to determine whether it should go forwards or backwards. Make sense? So if you told it to go forward 2 inches, it's positive 2, but if you told it to go backwards 2 inches, it's negative 2. The power doesn't determine whether it goes forward or backward, the distance does. And to ensure that, the writers of this program said take the absolute value of speed, because if somebody plugs in a negative, we don't want double negatives to come through and all of a sudden your robot's going forward when you thought it was going to go backwards. All right. We've turned it on. Now it needs to do something until it gets far enough in order to shut down. So we use a loop for that. In this case, we're going to use a while loop. And every loop needs to start with while op mode is active. It's kind of a fail-safe. If you press stop, it's going to throw errors on your robot. So while op mode is active. Now, I'm going to show you a couple of operators here. This means and. It's an ampersand. But if you put two of them together, it means and. So while your op mode is active, and a runtime in seconds, as it's counting down, it's using that timer function that before, is less than whatever the timeout was. So we told it to restart its, the runtime was reset up here, just moments before we turn the power on. And so if the runtime runs out, then it will shut down the program, because the op mode has to be active. In other words, it's playing. We didn't hit stop. And we haven't run out of time. Okay, that's another condition that can break it. And the two wheels are busy. So both of the wheels are driving. So as long as they're driving to their current position, they're busy. And as soon as they get to their position that we told them to go to, they won't be busy anymore, and it will break the loop. When either one of them gets to their position, it will break the loop. So as long as all of these things are happening, as long as your op mode is active, as long as you haven't run out of time, and as long as your wheels are moving, it's just going to kind of hang out and sit right here in this loop, going over and over and over again. And so they threw this in. It's going to give you some telemetry information. It's going to show you on the phone screen down here in numbers how close it is to its target position, so you can kind of see what's happening with the encoders. Sometimes using that to debug what's going on is very helpful. Once it goes to, once it breaks this loop, once the while loop is broken, shuts off the power and puts it back to a run using encoder as opposed to run to position. And so every time you type Encoder Drive, it does all that. But you don't have to see it every time. Imagine writing all of that stuff each time. Ugh. So Encoder Drive, what we've got here, it's telling it to drive forward for 2 inches. It's then supposed to turn a little bit, and then it's supposed to drive backwards for 2 inches. Okay, so those are a couple of things. We've got drive forward for 5 seconds. Actually, I'm probably going to change that to about 1 second. And when you want to update your program, you press this build button down here at the bottom. If you get any errors, they'll show up down here, but it told me build successful. So we're going to drive forward for 1 second. We're going to show all this working. And then we've got Encoder Drive, driving forward, turning a little bit, driving backwards. And then I've got this drive to color. Now, if you remember, the color sensor is using an alpha value, and it's saying 595. So I put it in front of this box, and it's saying the alpha value is now 821. I move it a little closer to the box, and it's going to say that the alpha value is 2009. Okay, so, all right. This is what I wrote based off of what they put in Encoder Drive. So I rewrote Encoder Drive into drive to color. So it will drive until it sees a color. Now, I use the alpha value, and we see here that it's 12. It's over 1200. So I said an alpha value of 1200. So this is how fast I want it to go. This is the alpha value. It could also be red, blue, whatever hue, whatever values you want to pull out of that thing, and the timeout. I set the timeout to 10 seconds because it would be obvious if it just drives past what I was trying to get it to stop at. Next, after it does its drive to color, and I'll go down and do that in a minute, it's going to set its spike to 0.6. And then depending on whether, this is a nice little simple program here, it's a conditional move for the servo. So this is going to make your servo move. So your robot, hey, spike, that's the name of the servo, set position to 0.6, and give it just a moment to do that because it does take it a second. And then this is an if-else statement. So if the color sensor alpha value is less than 1200, set your robot spike to 0.5. Otherwise, we're going to assume that it's otherwise, and it's going to go to 0.8. Okay, so if it's too light or if it's too dark, it's going to go one way or it's going to go the other. And give it a second to do that. Here's another way of kind of doing a different conditional move. Robot color sensor red is greater than color sensor blue. Okay, so if you got more red than blue, then move your servo one way or another. That might be pretty helpful. I just don't know what the competition is going to be this year, if we have to detect red or blue, or if they're going to throw some random black and dark colors at us like they did last year. And that's it. And then it's done. The program's over. Let me go back one more time and walk through the program. So this was the simple way of driving the robot. You just basically turn the power of the motors on, wait for some amount of time, and then shut the power off. This gets to be a little bit more complicated, but far superior. You're telling a speed, and then you're telling a distance for each wheel individually, and you give it a timeout. And it's going to follow that down and use the method that was written in order to follow that logic through. Now, this one here, drive to color, it's going to drive until the alpha value crosses this 1200 threshold. Move the spike depending on what the color sensor has, high or low, or if you see more red or if you see more blue, go one way or go the other. And that ends the program. And now down here we are in the methods. Okay, now if the program works the way that it's supposed to, the robot should power up for 50% power for half a second. I change it to that and then shut off. And then the encoder drive should kick in. It should drive forward 2 inches, and then it should kind of rotate 2 inches to the right, and then it should drive backwards for 2 inches. And then I'm telling it to drive until it sees a darker color and stop. So hopefully it'll stop right in front of that box. And then it's supposed to reset its spike to 0.6, and then depending on whether it's darker or lighter, it's going to go one way or the other. And then again, depending on whether it sees more blue or more red at this given point, it should turn to a different position, and that's it. Let's see what happens. Let's initialize. All right, we've got 0 positions on our encoders. We've got our alpha values, our initial reading. Let's hit play and see what happens now. Play. All right, there you have it. Thanks for listening to me today, and I hope we got a few minutes to answer some questions here. Again, I've got my email address up on the screen for anybody that might want to reach out to me later on, so you can jot that down and shoot me an email. I might be able to help debug some things. Let's go ahead and move on over to questions.